Now we are going to hear about scene control, mixed reality and enhancement via efficient scene editing by Ya-Ting, Yong-Liang, Gang, and Wenping Wang, and Ya-Ting is giving the presentation.
Okay, thank you for the introduction. And today I will present a mixed reality system for immersively scene editing tool, SceneCtrl. And just imagine that we want to redesign this room, and such as remove some furniture and replace some furniture, or relocate some furniture. So what could we do? In traditional, we could do paper planner, but it requires professional skills and it is not very intuitively. And also we could make small-scale physical models, but it is much harder. And we also could use some software to do this thing, but it is still harder for novice humans. And finally, the most easy way is we just move the physical objects. But if we want to design the room, we may have to move one thing for several times to find the best location. So it is not a good idea. And mixed reality is a good way to do such kind of modification for the room. But in previous application, we only add some virtual objects in the real scene. And there may be some problems, such as the virtual objects may be conflict with the real one, like the bookshelf showing here. So what if I want to replace the real bookshelf by a virtual one? That is it possible for us to delete or edit the real object in mixed reality? And the answer is SceneCtrl. We allow users to delete, move, and copy the real objects in Hololens. So there is a sample for the editing. First, we could select the real objects by sketching and then delete them. Then we could copy and move the sofa. And finally, we could add more virtual objects. Then we could redesign this room into a totally different appearance. And first, in order to select the real object, we have to understand the scene first. And the Hololens could scan the room and provide a low-quality mesh with many patches and without many and without any semantics. So in order to select an object from this kind of thing, we have to understand the thing. But it is hard to use some advanced segmentation algorithms in Hololens due to the limitation of its computation power. We just do the planar extraction, and we could do the segmentation based on them. And first, we classify the planars into floor, ceiling, wall, or desktop based on their location and orientation. And further, we remove the planars that we do not need and merge and resize the useful parts. And then we could segment. But we only do the segmentation on each patch because it is too expensive to merge all the patches in Hololens. But it will cause over-segmentation problem. So we use head sketching for the for selection, which could make interaction naturally for most users. And based on the positions of head and hand, we could project the hand moving paths on the object surface, and then we can select them. And second, To delete the real object, we use the virtual background to cover the object that we want to delete. So we have to reconstruct the textures based on the geometry. By default, we can only get the geometry information from HoloLens, so we let users to take photos for objects that they want to reconstruct. And then the photos will be blended incrementally in real time. And blending is necessary since the exposure and white balance may be different due to the different poses when we take photos. And real time is really important for the user experience, so we only use weighted linear blending on overlapped area instead of those expensive but advanced algorithms. And the weight is related with the distance to the boundary. But if the overlap area is too large, they will be slow, so we downsampling the boundary to improve the efficiency. And there are another problem due to the low quality mesh. That is, if we take a photo from the viewing direction in figure A, and when we see from the figure B, we will see that the geometry is pretty low and the pad is it's really a bad effect. So we apply dynamic texture, and we let users to take multiple photos from different views, and we generate the texture based on the current viewing direction. And now we have the reconstructed geometry and texture, so we could delete the real object. And furthermore, based on the reconstruction, we could also move and copy the real object as well. And there is a demo. And this is the original room. And after scanning and take pictures for walls, sofa, and floor, we could get the reconstructed mesh. And this is the menu for the virtual models. And then we could use hand to draw lines to select the sofa. And you can see the sofa consists of two parts, but we could draw one line to select it. And then we could select multiple objects and delete them. It is actually covered by the walls. And then we could copy this sofa. And the latency is caused by video capturing. In practice, all the interactions are in real time. And then we could also add some virtual models with simple resize and rotation. Then we could redesign this room, and I will show more results here. And in this case, we keep the sofa without any editing, and we can see the real sofas directly. And then the other things are replaced by the virtual bed and lights. And in this case, we delete the chairs and the toy on the table and put some X-baits to change the room into a gallery. And of course, we could also edit the outdoor space. But we do not need to reconstruct the entire space, and we only need to reconstruct the parts that are highlighted by the red box. That is enough for deleting the tables. And here is a simple comparison. In HoloLens, if we do not delete the real object, the virtual object will be conflict with the real one. And in traditional AR, all the virtual objects are above the real object and cannot provide the correct depth relationship. And to evaluate the SceneCtrl, we recruited 10 volunteers, ages from 20 to 30, including 4 females. Only 1 participant had experience of using HoloLens before. At first, they learned the usage of our system, and they usually could finish the learning in 15 minutes. And after the learning, they were asked to redecorate the 2 different rooms. And immediately following the testing, we asked them to fill out a simulator sickness questionnaire to evaluate their overall comfort level. And the mean value is much lower than the normal ranges for playing stereo video games. There is no big movements in our case, and users could see the real world through HoloLens, so it helps to decrease the nausea and disorientation. And then the participants were asked to rate the overall satisfaction and some other questions about system usefulness, usability, enjoyment, and visual experience for these 2 things. And in general, all the participants think SceneCtrl is useful and the edit processing is interesting. And almost everyone said it is really surprised that they could delete the real object. But of course, we still have some limitations. First, the dynamic texture quality highly depends on the photos that user captured. So if we want to get better quality, users have to pay more effort to do the capturing. And the second, the key point of delete is covering, but the dark virtual object is hard to cover the bright real object, such as the things shows in Figure A. But on the contract, the effect will be better. And in the future, we would like to employ state-of-the-art scene understand techniques to analyze the semantics of the table chair in the scene. And for the lighting condition, we currently allow the users to manually add and adjust the lighting source. But it will be better if we use inverse rendering to faithfully estimate the lighting condition in the real scene. Okay, thank you so much.
Hi, David Lindelbaugh, TU Berlin. Really cool work.
Thank you.
Did you consider blending the colors of the physical object and the virtual objects to get better kind of better appearance, so that it looks nicer? Because currently you're not taking into account these 2 things.
Do you mean we can see both color of the real and the virtual?
Yeah, and those mix. But maybe they have the result is not what you want.
Yes, in some case we could see the real objects as well, but when we put on the HoloLens, our concentrate will be attracted by the virtual things. So maybe we could see the real things behind it, but it's not really. It is not really bad experience, yeah.
Hi, Evan Strasnick, Stanford University.
Thank you.
It's a really good job. I really like it. I I was curious, so obviously the HoloLens is a great platform for development and is very useful in that way, but what was the rationale behind choosing an optical see-through AR approach as opposed to a video see-through AR approach? Obviously, I think what we actually see through the HoloLens will have issues of opacity, right? Whereas with the video see-through approach, you have a lot more flexibility to change the visuals.
Yes, we choose the see-through device because I think that it is more natural for users to see the real things directly. And if we based on the pad, we have to hold it. And so the HoloLens seems to be better for the user editing things. Right.
Thank you.